Hello, this is Professor Salahat again. We're going to continue with homework 7, chapter 9, and I'm looking at problem number 14 now. And in the problem here, they tell us to use this table, and they give us x and y. And then after that, they ask us to look and try to generate the scatter plot first. So to do that, I'm going to open the data into StatCrunch. Then after that, I'm going to try to generate the scatter plot following those steps. Stat, regression, simple linear. The x variable will be x, as they tell us, and the y variable will be y. And just hit the compute and move this slightly. And you're going to see there is an arrow in the bottom there. We press on the bottom, and this is the graph we get. So let me just move this aside and look at the graphs we have. And in this case, the scatter plot cannot be A because A is kind of flat in here, and the dots is kind of standing on top of each other. It cannot, I mean, it is a possible thing. It's going to be, again, it's not going to be A because look at this. This is the 0. There is data below in the native in A and data above A in the positive side. So our data is all above the x-axis. There is no natives. That's the reason why we eliminated A. In B, I mean, B looks like it is okay, but let's look at C, D, and so on. So in this case, if you want to really get the best graph possible, make this large enough for you to see, and then enlarge every one of those graphs. So if you go to this one and make it larger, notice that our dots here is 3 dots, then 1, 2, 3, and there is a 1 missing. The missing one is in here in the bottom. Okay, which is this, but there is another one missing. So because we have a total of 1, 2, 3, 4, 5, 6, 7, 8. Here we have 3, 6, 7. I don't see the 8th point in there. So maybe it is there, maybe it's missing. But let's look at the other ones. The other ones in here, let me make this large. We have 3. And we have 3 here, and we have 1 on the line, but the 1 in there is missing. The one a little bit above 40 is missing there. So it's not going to be the B. What about the, I mean, it's not going to be the C. What about the B? Let me see the B. I looked at the B here earlier. What about the final one, which is this point? And in here, notice that there is values that are, look at this, there's a negative 12 in the bottom. So there's negatives and positives. So again, we're going to eliminate the A and the D because there is positives and negatives. And when it comes to the solution, I'm going to also eliminate the C because in the C, there is a dot that is on the line there. And this one has no dot on the line. Okay, so we're going to eliminate that. And hopefully we're going to get to the B. Now, when you look at the B here, some of us say, but this is also on the 0 axis. Okay, so this is not really a perfect graph, and it's missing a dot there. Okay, so that dot is missing. When it's x, it's 41 because our graph is limited to 40. So we're just going to assume this is the correct answer. So let me enlarge the graph, and I'm going to assume this is the correct answer. I mean, this is my best bet for a correct answer. If you look at the graph in here and look at this one, this is the best bet. Okay, don't forget the line. Okay, so let's just double check and see. Check the answer, and it's the correct answer. The next part of the problem, and let me maybe make this smaller for us to see. They're asking us, or they're asking about an outlier. Now let's look at the picture in here. All the points here are clustered here, except a point down there that is far away from the rest. That is our expectation, that this point will be the point that is outlier. And if I move the mouse over it and I hover over, it tells me this value is row 8, and row 8 where it is x is 41 and y is 0. So this is the last number of piece of data. So it's going to be 41, 0 will be my outlier. That's obvious outlier because it's far away from the rest of the data. So let's double check in here. and it's going to be a good answer. Now, if we continue in here, they tell us, okay, determine if the point is influential. The change in slope or intercept is significant if it is larger than 10%. Now, what makes the point influential? Let me go back in here and do this data with and without. Now, look at that here, and we're going to go regression, symbol linear, and we're going to choose X, and we're going to choose Y. And what makes it influential, the definition here says, if the change in slope and intercept is significant and larger than 10%. Let me tell you what I mean by that, or what they mean by that. Look at our slope here. Our slope, M, is equal to native 0.95, and our intercept, B, is equal to 38.7, let's say 4. Again, if you want to look in here, you can find them in the equation there. Here's the equation. And the slope, always the number in front of X. So this is X, and this slope is in here. And it's going to be native 0.95. And the intercept is the number by itself. And we're going to round it here. So this is with the point. Now, what about without? Without means, go back to your data. And we said this point, 41, 0, is influential. So remove the 41 and 0. Delete the 0 and 41. And repeat the steps again. Do the stat, do the regression, do the linear, and go find the X and Y, and go calculate everything. So with that, here's the slope. Without the slope now is going to be 0.99. Okay, native 0.99. And the intercept is going to be equal to 39.24. So let me put this away for a minute and comment in here. They say the change in slope or intercept is larger than 10%. Let's take intercept, for example. The intercept changed from 38.74 to 39.24. Notice that 10% of 38.74 is equal to 3.87 something, because 10% is just move the decimal one place. Now look at the slope. Did the intercept change by 3.7 or by 3.8? The slope in here, the intercept in here is changed by less than 1. So this tells me it is more than 1. So in this case, the slope did not change by 10%, changed by way less than 10%. Therefore, the point is not an influential. Again, it is influential if it makes a change. It will have a big influence if the change it creates more than 10%. And in this case, we notice that the change is less than 10%. So therefore, it's not influential because the slope with the point included and without the point included. Remember, you can take the slope or intercept, any one of those, because in here it says or, one or the other. I did the intercept, you can do the slope. You can, the same thing about the slope. So the slope, whatever, included with and without. Okay, it says in here, with the slope included and without the point included are significantly different. In this case, it's not significantly different. It is very close. And the intercepts are the same thing, are not significantly different. It is, in other words, look at the intercept. The intercept changed slightly, and look at the slope. The slope in here changed slightly from native 0.95 to native 0.99. So the change in here is not very big in both of those. So if we check the answer in here, it's going to tell us it's a good answer. So yes, that point that we looked at here is let me go back to the graph. The point we looked at here is far away from the graph, but it's not a significant one. Why? Because it's still close to the line. When we drew the line, it is close to the line. Now, the question after that, which is 15, talks about probably similar stuff. Number 15 says, police sometimes measure shoe prints at crime scenes so that they can learn something about criminals. So again, the criminal is gone already, but they leave a footprint. So can we predict, in this case, in here says, list They gave us a list of shoe prints and the heights of criminals already that we know of. Okay, so we know about the every time they arrest a criminal or something, probably, I'm not sure, but they measure the foot shoe print in there and the height of the accused, let me call instead of criminal. So police below listed those results, and in this problem here it says construct a scatter plot, find the value of the linear correlation R and the p-value of R, determine whether there is sufficient evidence to support a claim of linear correlation between the two variables. So in this case, let's just try to do everything all at once, and I'll show you exactly. Everything they ask for is available here. Open a StatCrunch, then go to Stat, and go to Regression, and go to Simple Linear. And notice that in here, we know the shoe print that is given, and we want to predict the height. That is what we're trying to predict. Now, in this case, I'm just going to do those two things and hit compute. And there is a wealth of information here that I'm going to show you what we're going to need it for. So let me go here and try to answer the problem as we go. The first thing is they are asking me for matching the scatter plot with what I have there. So when I go to the scatter plot, and please ignore the red line, which graph matches the scatter plot? Now, in this case, this can be a tough task. So you need to focus exactly on what's going on in here. Notice, let me just pull one at a time. Look, in this one in here, it seems like the points, look at that number 28. The number 28 is in here, and the points are clustered around 28. But in here, it seems the graph says the points are clustered around 32. So A is not a correct answer. Now, B, the points are clustered around 32. Let's leave it for later. And C is the points are clustered around 28. It's not a good answer. D, the points are clustered around 32. So it's going to be either between B or D. Okay, so let's try to make B large again. Notice that the points are clustered around 32, and they go down up to 28 or a little bit under 28, which is good because this is 28 and they go a little bit under 28. So it seems like this graph is reasonable, B. Let's look at D. In D in here, they tell you the points are clustered around here, and it's, again, this is also reasonable. So how are we going to determine which graph is the correct graph? Now, try to look at the points in here, like to match the points. Look at the points in there. So try to look at this. It seems like this is very close to the correct graph, which is D. But look back at B. At B in here, you see that here the dots are in the correct graph. The dots are side by side. Here, the dots are above each other. So it's not more reasonable to have B, but it's more reasonable to have the D. Again, we can enlarge the D for you to see it again. It is very close. We're going to choose the D as our answer, and that will be the correct answer. So you have to look like you're looking at clues to match the two graphs. Now, what is R? Let me go back with the arrow, and here is R. R in this case is 0.15, and they want 3 places. 15, 98 something, so it's going to be 160 because we need to round to 3 places. The next question will be, what is the null hypothesis and alternative hypothesis? So I'm going to go in here and try to write those two. So this is H note and this is HA. Both of them is going to be claims about rho, which is rho in this case is the correlation coefficient of all. So in this case, and let's look at this. Determine whether there is here sufficient evidence to support the claim. What is the claim? The claim that of linear correlation. Notice that when we did the math earlier, we said when it's 0, there is no correlation. So in this case, if we assume it is 0, there is no correlation. If you assume it's not 0, there is a correlation. Okay, so the claim will be, in this case, our claim will be statement 2. because statement 2 says test the claim. What's the claim? There is a linear correlation between the two variables. So to do that, this is my statements. I go in there and I put equal in the top and not equal in the bottom. And in this case, we put 0 and 0 because 0 is the cutting point, like between correlation and no correlation. So let's check the answer. And the next step is, what is the t-statistic? So again, let me go back to StatCrunch. Now notice that when I look at my results, the t-stat is, look at the slope, look at this row, and look under statistics, and look under stat and under slope, and what you see, you're going to see this number. That is the t-stat, and the t-stat in this case is going to be point, and again, we need two places, going to be 0.67. So if I check the answer, it's going to give me the correct answer. The next thing is they ask us to find the p-value. The p-value is the value under p-value here and across from slope. So this is the p-value. It's not the top one, it's the bottom one. It's going to be 0.5, and again, I need three places, 5, 1, 3. After that, they ask us to make a decision. So let me put this down and try to show you how we're going to make the decision. Now we're going to make a decision based on p-value and alpha. Notice alpha is given in the problem to be 0.01. Here is alpha. It's given here. So alpha is 0.01, and the p-value we found is to be 0.513. Notice that the p-value is greater than alpha. In this case, we fail to reject H naught. So let's go back. Fail to reject H naught. Here's our problem. We're gonna fail to reject H naught, and we're gonna reject HA. And if you reject HA, you're rejecting the claim. So the decision in here is to reject the claim because the p-value of the linear correlation coefficient is greater than, it happened to be greater than, again, in here we get it greater than the significance level. There is sufficient evidence to support the claim. Because again, why we support the claim? Because the claim happened to be, we're rejecting the claim. So there is not sufficient evidence to support the claim. Okay, again, when you reject the claim, there is not enough, or there is not sufficient evidence to support the claim. So that is our answer. I hope that was clear. Again, if the p-value is bigger than alpha, we fail to reject H naught. Fail to reject H naught, okay, it means that you're going to reject HA. HA happened to be the claim, therefore the claim is rejected. What is the claim? The claim is, here's the claim stated up there. It says the claim is what? There is a linear correlation. So in this case, there is not sufficient evidence to support the claim that there is a linear correlation. Now, I'm going to go to the next one. Okay, in the next one in here, I'm going to click on this icon because the problem is in here really. And another thing, I'm going to make this large for us to all see. And in here, they gave us 4 different values of R. They gave us, if you look at that line in here, it says we have 4 different values of R. The first R is 1. 1 means perfect increasing. 1 is positive, first of all, and it is 1, it is perfect. So the perfect one is probably this graph in here, plot 5. If you look at plot 5, it seems it is positive going up and linear. So in this case, we're going to go in there and say number 5 here, scatter 5, is R equal to 1. Now, if you look at scatter plot 2, it is perfect, but it's decreasing. So it's going to be the negative 1. So scatter plot 2 here is the negative 1. Now, if you look at number 4, notice that number 4 is going up, so it's positive, and the points are very close, but it's not straight. So it's going to be closer to 0.8, 0.9, whatever, and notice that there is 0.9 in there. So scatter plot will be the 0.9. Now, what about the rest of them? Notice that the rest of them here, let me make sure if I can make this bigger. Maybe I can see, but maybe not. Look at this one. Those in number 1 is going down, and in number 3 is going down. But notice that if we compare number 1 to number 3, we notice number 1, the dots are going down and closer to each other. So because both of them are going down, it's going to be native. But in 1, it's closer, and it's closer means it is closer to native 1, and therefore for scatter 1, we're going to choose the native 0.73. And for the number 3, we're going to choose also a native, but what's left is native 0.376. So if you do this and you check your answer, it should give you the correct answer. Now, the one after is just, we talked about this in the live lecture, is that in here they tell you, if we read the problem in here, it says different hotels in a certain area are randomly selected and their ratings and prices were obtained online. Using technology with X representing the rating and Y representing the price, we find that the regression equation has a slope. So they gave us a slope of 140. And they give us a y-intercept, which is native 363. And they ask us to write the equation. Notice always the regression equation is always going to be like this, mx plus b. So in this case, just do the substitution. Y hat will be m, which is 140x, plus b, but b happened to be native. Notice that you can reverse the problem if you want to. You can write it like this. Y hat equal native 363 plus 140x. You can reverse those two as long as the native sign goes with the second number. And again, remember, this is a regression equation. You have to have the y hat. So which one is going to be either A or D, because it has y hat, y hat. And in this case, we're not going to choose A because A says y hat and x hat. Remember, x is not predicted. We're only predicting the y. So we're going to choose the D, and then we're going to plug in the numbers. It's native 363 for the intercept, and for the slope is 140. And that should give us the correct answer. Now, what does the symbol y hat represents? We just mentioned. The symbol y hat represents the average price. No. It represents the predicted value of price. Yes. The symbol y hat represents the expected. No. It's represented the amount that price increases with whatever. No. So it is this one. It is the predicted. Okay. So we're gonna get this answer in here. So I'm gonna stop the recording here.